Good morning, everybody, and welcome to our pre-calculus class today. Um, Thank you for joining us. Today, what we're planning on doing is to kind of summarize what Chapter 5, uh, what we're discussing in Chapter 5 and what we talked about in Chapter 5. Now, I've already written all of these down, so what I'm going to do is I'm just going to go over it very quickly with you, and then we're gonna try to spend a little bit of time on answering some questions and going over some of the questions on our review booklet. So, in terms of chapter 5, we talked about exponential function and the graph of exponential function. So, the form is the general form is y equals to b to the x. And then this uppercase b represents the base. So it says where b is the base. And we're looking at the base when the base is greater than 0. So when we talk about the exponential function, the key points are 0, 1. So what does that mean? It means that if x is 0, and you put the 0 there, whatever the base is to the exponent 0 is 1. And then the other key point is 1 comma b. So that means if I put 1 for the x, y will be b, right? B to the 1 will be just b. And what we're going to do is we're actually going to be creating this graph. So this is going to be the 0, 1 point. And then this one is going to be the 1b point. And the graph will look like this. We will see that there's going to be a horizontal asymptote at y equals to 0. So this is the horizontal asymptote at y equals to 0. After we learned about this part here, we talked about the transformation of an exponential function. And this is the form of the transform exponential function. Y is equals to a, the parameter a times b, whatever the base is, to the exponent parameter b times x minus h plus the k. And I just wrote down some mappings in that one. So we can use an xy information in here. So the basic the key points are 0, 1, and 1b. And then we can use the transformation in here. Okay. And it says here, a horizontal asymptote at y equals to 0 is translated by the parameter k. So in this particular case, as the vertical translation for parameter k will move the horizontal asymptote up or down, up or down. Okay, so that's what the summary of our exponential function. Now looking at the logarithm function, and don't worry about writing this down. I will post this online, and right now what we're doing is we're just gonna go over it and talk about it. So don't worry about writing it down, okay? Because I'm gonna do this very, very quickly. So logarithm function is in this form: y equals to the logarithm of x base b, and then the b would be our base. And I wrote down over here, remember that exponential and logarithm functions are inverses of each other. So that means the x values, the domain for the exponential function will be the range of the logarithm function and vice versa. So when we look at the key points are 1, 0, and b is the base, comma 1. Okay, so these are the key points. And I just want to point back here because they're inverses of each other. Okay, so if we look at the exponential function, okay, you can't see that right now. Exponential function, it's 0, 1, and its inverse, the logarithm function, is 1, 0. And then over here, the in exponential function is a key point would be if x is 1, y is b, and then the logarithm function, its inverse is b comma 1. So um, now in this particular case, this is what the graph would look like in logarithm, and there is a vertical asymptote right here at x equals to 0. And again, when we look at the logarithm function, we were able to look at its transformation. So this is the form y equals to a times logarithm of b times x minus h plus, uh, sorry, a times logarithm operating in base b of b times x minus h and then plus k. So this is not right. I'm going to fix this one here. So this is going to be logarithm of base b times b x minus h plus k. Okay. So, and again, I wrote down the mapping. So this is the mapping that we've done. I mean, we've done so much of the mapping, so I will just leave it like that. So vertical asymptote of x equals 0 is translated by the parameter h. So this is the vertical asymptote. The only time that the vertical asymptote will be moved is if we have a horizontal shifting left or right. Okay, and then the translation left or right is based on the h value. Okay, so now what else did we talk about? In terms of this chapter, we talked about writing exponential expression or equation as logarithm and vice versa. So we can write down a logarithm and express that as a exponential form. So logarithm is really looking for the exponent. So that means, what does this mean? What exponent do I need to raise 3 to get a 9? That would be 2. 3. So that means 3 squared. 3 squared will give us 9. So the 3, that's your base. This is your exponent, and then whatever that is equal to 9. Now I'll take a look at this one. What if we go the other way around, from exponential form to logarithm? So that means this is the base 4. So that means log base 4 of 16 is equals to 2. Because remember, logarithm is figuring out what the exponent is. So figuring out the 2. So the 2 there. So we did some examples of that. So changing the expression from logarithm to exponential, and an exponential to logarithm. And this is one of the important, I guess all of them are important, but this is important because we're going to use this information or this strategy when we talk about solving equations. And then over here, I actually put them side by side, loss of exponent and loss of logarithm. We talked about simplifying and expanding. So here, we're looking at a to the m times a to the n. I changed my base to a earlier. So what do we do when we multiply powers? We add the exponent. That gives us a to the m plus n. What if we have a to the m divided by a to the n? So what do we do when we have power divided by a power. So that would be a to the, we subtract the exponents, m minus n, and then a to the m to the power of n. What do we do to the exponent? It's going to be multiplied, m times n. And this is one of the, if we see this, a to the power of 0 is equals to 1, and a to the exponent negative n, we can rewrite that as a positive exponent by taking its reciprocal, so taking this in the denominator to make it a positive exponent. So this one is a summary of the laws of exponents, this part here. And then over here, this is a summary of the logarithm laws. So I changed, when I was writing this, I changed it to base A. That's why it looks like that. So logarithm of m times n base A, we can expand it, which is also equal to logarithm of m plus logarithm of n. Can you see here? Exponents are being added. Exponents over there is being added. So I just want to show that parallel to you. Logarithm of m divided by n is equals to the logarithm of m minus logarithm of n. So what happens when you're dividing, we are subtracting the exponents, as you can see here. Subtracting exponent, subtracting exponents. And then here, log of m to the n is the same thing as n times log to the m. Just want to be consistent here. M. Okay, so that's that. And these are the key things. So log of a base A is 1, and then log of 1 base A is 0. Now, talking about solving equations, exponential equation, there's two different kinds of equation that we've seen. We've seen equations where we can write or express as the same base. So if it can be written as the same base, we can do that. Or another thing is, if we cannot write using the same base, we might have to use logarithm rules or logarithm laws. So again, don't copy this down. I'm going to talk about this very, very shortly. And then lastly, we're going to be talking about solving logarithm equations. So solving logarithm equations, we might have to simplify and use logarithm rules, or expand using logarithm rules. And then finally, we might have to use the exponent laws and then to solve for whatever we need to solve for. Okay, so that was a kind of like a quick overview of what we've talked about. So let's go ahead and take a look at some of the questions from the book. I'm going to try some of the questions from the book in here. And last week, I mentioned that we get started working on some of these questions. And this is on page 444. So looking at page 444, the review, I'll go over some of these questions. Oh my gosh, this is backwards here. Okay, so page 444. Yes, much better. Okay, so here it says here, like I said, I'm gonna go over some of these questions and go as far as we can until we're So it says here, complete the table of values, then graph. So the graph of y equals to 1/4 to the x. So how do we go about with this one? Uh, the table of values is pretty much created for us. So what we're going to do is we can go ahead and substitute the values x for this and solve for y. So in this particular case, in this particular case, maybe I'll do that on a separate sheet of paper, so it's probably easier. So this is page 444, review. So y equals to 1/4 to the x. So they're already giving us what the x values. So we're just going to figure out the y. Somehow I like x and y vertically like this. So -2, -1, 0, 1, and 2. So if x is -2, so I'm going to put a -2 there. Because it's a -2, that's the same thing as 1/4 to the -2. We can rewrite that as a positive exponent by taking the reciprocal, so 4/1 to the exponent 2, and 4/1 to the exponent 2, that's going to give us 16. So our first point is -2, 16. Now the next one is 1/4 to the -2. -1. What we're going to do is we're going to write that as a positive exponent. So by taking the reciprocal, so it's going to be 4/1. Now it's exponent 1. So 4 to the exponent 1 is 4. And then what if x is 0? So 1/4 to the 0. So we said earlier that anything to the power of 0 is 1. So 1/4 to the exponent 0 is 1. So that one's easy. And 1/4 to the power of 1 is going to be 1/4. And then 1/4 to the power of 2, that's going to be 1 squared is 1. And then 4 squared is 16. So it's 1/16. So if you were to graph this, I'm just going to do this on a graph on the side here. We're going to have an exponential function where it's -2, 16. Okay. Okay. Probably going to start with -1, 4. So -1, 1, 2, 3, 4. -1, 4 is there. And then 0 is 1. 1 is 1/4. And then 2 is 1/16. It's getting smaller and smaller as we go to the right. So the graph will go like this. Okay. So this is called a decreasing. It's a decreasing exponential function because as you keep going to the right, the value decreases and decreases. Okay. So that's that. Asymptote is right here. Is at y equals to 0. So that's the horizontal asymptote. Okay, so that's question number 1. Now let's take a look at question number 2. Question number 2. It says here, graph y equals to 3 to the x for -2 to +2. Okay, so what we're going to do is we're going to graph y equals to 3.5 to the x. And they're telling us we're only going to graph it from -2 to +2. Okay, so let's just do that one. So -2, -1, 0, 1, and 2. Okay, so this one here, 3.5 to the exponent negative 2. Now we can use our calculator for this one here. It's going to give us a decimal value, and that's okay. So 3.5 to the exponent negative 2 is going to give us negative 0.081. 0.081 approximately. 3.5 to the negative 1 is going to be approximately equal to, so 3.5 to the exponent negative 1 is going to give us, 0.286 approximately, rounding it off to 3 decimal places. And then this one here is going to be easy. 3.5 to the exponent 0, and that's exactly 1, because anything to the exponent 0 is 1. And then 3.5 to the exponent 1 is 1. Okay. And then 3.5 squared, whatever that is, so 2.5 squared is equals to 12.25. So now that we have the table of values in here, we could create our graph. Okay, so we can use a scale. We can use a scale of 1 if you wanted to, or a scale of, so I'll go scale of 1. So negative 1, negative 2, negative, positive 1, positive 2. And then we can use a scale of 1 as well if you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12, 13, 14, 15. So that just kind of shows us a scale of 1. So the very first one here, if x is negative 2, and it's going to give you 0.81. So it's going to be like really, really, really close to 0 right there. And if it's negative 1, it's going to be 0.1, 0.0286. And then 3.5 is 1. 0 is 1. And if it's 1, it's 3.5. So 1, 2, 3, 3.5 would be over here. And 2 would be 12. Okay. And then we're going to have a graph kind of going like this. Okay. Again, we have our horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. That's this one here. Okay. So, actually, I'm going to make a correction in here because we are interested only from negative 2, the domain of negative 2 to positive 2, and not going any further. I actually don't need the arrow on each end. So this is just going to be like that. So let's erase the arrow. Okay. So if you have any questions during this time, let me know and then we'll try to answer that. Okay, so that's question 1 and question number 2. This is from going over, I'm just going to type it down. We are going over the review questions on page 445. Okay, so that's that. Okay, so now let's take a look at question number 3. Oh, no, we're not done with number 2. It says here, that's just the A part. says determine whether the function is increasing or decreasing. So this is letter B of that. So B, this is going to be an, because the function, when you go to the right side, it gets bigger and bigger and bigger. So this is an increasing function. So that's one. And then what are the intercepts? So there are no x-intercept in this particular case, but y-intercept is equals to y-intercept is equals to 1. Okay, and then number 3, equation of the asymptote. Equation of the asymptote, that's going to be y equals to 0. Domain of the function, domain is from negative infinity to positive infinity. And then finally, the range would be from 0, but not including 0 to infinity. Okay, so this is an increasing function. Should complete this. No x-intercept, no y-intercept, and then y equals to 0 is the horizontal asymptote. Okay, so there we go. We finished question number 2. Okay, so if you have any questions, yeah, feel free to type it in, or you can email me later. Let's take a look at question number 3. Let's see if we can figure this out. Now it says here, okay, I'm just going to read this first. It says here, use technology to graph each function below. For each graph, identify the intercepts and identify the equation of the asymptote and state why it's significant. Okay. Let's take a look at number 3. Now it says here, use technology to graph. We actually don't really need technology to graph this one. So we can say y equals to 0.8 to the x. So because this is an exponential function, we're looking at the key points here. The key points are if x is 0, y is 1, and when it's 1, it's going to give us the base. So the key points are 0, 1, and 1, whatever the base is. Right? That's what we said at the beginning. So in this particular case, if x is 0, if I put 0 there, y is 1, so 0, 1. And if I put 1 there for x, and it's going to be 0.8 to the 1, it's going to be 0.8. So 1 comma 0.8. So that's, yeah, so we didn't really need the graphing technology for that one. So let's take a look. Okay, so the key point is 0, 1, 0, 1, and then 1.8. So 1 and then it's 0.8. It's right there. So as this increases the exponent, it's gonna decrease this way. Okay, so that's what the graph looks like. And then now, what else do we need? Identify the intercepts. So identify the intercepts. So in this particular case, there's no x-intercept. Okay, x-intercept, none. And then the y-intercept is equals to positive 1. Positive 1. What else do they need? Equation of the asymptote. Equation of asymptote. And the equation of the asymptote is a horizontal asymptote this way. So it's going to be y is equals to 0. Okay, so that one is not so bad. As long as we know some key points in here, we can trace out what's going on. Okay, so now let's take a look at question number, oh, there's a letter B to that one. Three B, where we have y equals to 2.75 to the x. Okay, so this is an exponential function. And because it's an exponential function, we can say these are the key points in our exponential function. It's going to be 0, 1, and it's going to be 1, whatever the base is. In this case, it's 2.75. Yes, it's 2.75. So here we go. So the x, y would be, if x is 0, so if I plug in 0 there, it's going to be 2.75 to the 0 is 1. And if I substitute 1 for the x, I'm going to get 2.75 to the 1, which is 2.75. So the graph would look like this, just kind of like a sketch. So it's going to be, I can go 1, 2, 3. There you go. So it's going to be 0, 1. So that's this point right there. And then 1, 2.1, 2.75. So 2.75 this way. And we know that the exponential function goes this way. And this is going to go here. And this is the asymptote right there. Okay. So again, let's figure out the intercepts. There's x-intercept, none. So we put none because it doesn't cross the x-axis. There's an asymptote there. And there's a y-intercept at 1. That's right there. And the horizontal asymptote is y equals to 0. Okay, good. So we've done questions number 1, 2, and 3. Now let's go to question number 4. What does question number 4 says? Question number 4 says here, now we're going to have some kind of a transformation going on in here. It says sketch the graph of y equals to negative 1/2 times 3 to the 2x minus 1. Okay, so let's write that down. Y equals to negative 1/2 times 3 to the 2x minus 1. Now, before I go on to this one, I want to say, well, what's going on in here? The basic exponential function is y equals to 3x. Now we have a is equals to negative 1/2. So that means there's going to be a vertical reflection into the x-axis, and there's going to be a reflection into the x-axis. That's our vertical reflection. So that's talking about the negative there. And then the 1/2. 1/2 tells us there's also a vertical compression. Vertical compression by a factor of 1/2. Okay, so I just want to, now the basic one. The other thing that we see that there's a b here. B is equals to 2. So what does that mean? There's a there is a horizontal horizontal compression of the factor 1 over b, which is 1/2. So horizontal compression of the graph by factor of 1/2. And I don't see any h, so h is equals to 0. So I'll just put here h equals to 0 means, oops, I'm not looking at my screen here. So h equals to 0, that means no horizontal shift, no horizontal translation. And then we see a k is equals to -1, so that means vertical translation 1 unit down. Okay, so we already figured out the parameters a, b, h, and k. And then now what we can do is we can use the mapping to figure this out. Okay, and then we'll do the graph. Okay, so here we go. What can we do? We do mapping. If I just look at the most basic graph, would be 3 to the x. That's without the transformation. Now with the transformation, it's going to be y is equals to -1/2 3 to the exponent 2x minus 1. So in this particular case, this is my xy point, and then over here will be the mapping. So it's going to be 1 over b, 1 over b, so it's going to be 1 over 2 times x plus h is 0, so plus 0. I'll just put it in there so we know where those numbers are coming from. Okay, and then over here, the transformation with the y would be a times y. So a is -1/2 times a. Okay, -1/2. So times y plus k. So plus k plus -1, so -1. Okay, so let's take a look at some key points in here. What's going on in here? There is the key points for that one would be 0, 1, and then 1 comma base, which is 3. So we can use these 2 key points and use that for the mapping. So let's take a look at the x. So if x is 0, 1/2 times 0 is 0, plus 0 is 0. And then the y would be -1/2 times 1 would be -1/2 minus 1. So it's going to be -1 and 1/2. So -1 1 and 1/2. Okay, that's that. And the, the next one, if x is 1, so 1/2 times 1 is 1/2, plus 0 is 1/2. And then this one here, if y is negative, y is 3, so negative 1/2 times 3, so that's negative 3/2 minus 1, negative 3/2 minus 1, so it's going to be negative 5/2, negative 5/2. Okay. Okay, so what does that graph look like to us? Now, because the graph is translated 1 unit down, our horizontal asymptote at 0 initially will go down 1 unit as well. So this is what the graph would look like. Translated 1 unit down. Okay, and let's see the points. It's going to be negative 1 and negative 1 and 1/2. For 0, negative 1 and 1/2, that would be over there. And a half is here. It's negative 5/2 is negative 2.25. So negative 1, negative 2, negative 2.5, negative 3. This is 1. This is 1/2. So the graph looks like this. So does that make sense to us? So if we just graph this one in here, that's going to give us a graph looking like this. But because there's a reflection into the x-axis and everything shifted down, so now it's over here. And there's also a compression by a factor of 1/2. So it got really, really squished. So that's what the graph would look like. Okay, so how are we doing for time? Okay, so we have up to question number 4. Let's take a look at the next one. We'll go as far as we can with these ones, and I'll give you the rest of the time to work on some of these. And so, for example, number 4, or question number 4, next page, letter B, it says here, is the function increasing or decreasing? So when you look at this one in here, it's going down. So this is a decreasing function. Number 2, what are the intercepts? No x-intercepts. But y-intercept is negative. Okay, how do we calculate the y-intercept? We set x equals to 0. So it's going to be at negative 1 and 1/2. Okay, so if you want to calculate the y-intercept, we can set x equals to 0. And then that will give us 2. And if you go that way, negative 1/2 times 3 to the 0, 2 times 0, minus 1. Right, so it's 2 times 0 is 0. So that becomes negative 1/2. 3 to the 0 is going to be 1 minus 1. So there's our y-intercept. Negative 1 and 1/2, so negative 1.5. Okay, negative 1 and 1/2. Equation of the asymptote. Asymptote would be a horizontal asymptote at y is equals to negative 1, because everything is shifted 1 unit down. So that's our horizontal asymptote will go down 1. And the mean is from negative infinity to positive infinity. And then finally, range is from range is from negative 1 to negative infinity, because we go from lowest to highest. So negative 1 to negative infinity to negative 1. Okay, so that completes number 4. I think what we could do is we could probably complete some of number 5, and then we'll go on from there. Okay. This is number 5. So this is the review questions. This is going to be now on page 446, question number 5. So this one talks about solving equation. So the very first one says solving the equation 4 to the x equals to 128. Now, how do we go with this one here? Now, 2 ways we can solve this equation. If we can write it as the same base, that would be great. And if not, we have to use the logarithm. But in this particular case, 4 and 128 actually can have the same base of 2. So 4, we can write it as 2 squared to the x. And then 128, that's going to be 2 to the 7th. Okay. So 2 to the exponent 7 is 128. So now that they have the same base, we can figure out just the exponent. So that means 2x is equals to 7. So solving for x, divide by 2, divide by 2. So x equals to 7/2, which is 3.5. Okay, so if you want, we can check it. We can check our answer. Let's see. 4 to the exponent, we're going to put 3.5 there. And I get 128, which is correct. Okay, so now let's take a look at letter B. Letter B, 5B. Now 5B is 27 to the exponent x plus 1 equals to 81 to the exponent x minus 2. Okay, so 27 to the exponent x plus 1 equals to 81 to the exponent x minus 2. Now, it's just a matter of figuring this out, because 27 and 81, is there looks like they're starting off with not the same base, but they're actually, in fact, they could be written as the same base equation, because we know 27 is 3 cubed, right? So 27 is 3 to the exponent 3. 3 cubed is 27. Now 81 can be written as 3 to the exponent 4 is 81. So 27, I can go 3 cubed to the exponent x plus 1. And then 81, I can write that as 3 to the power 4 x minus 2. And then from here, what I'm going to do is I'm going to use the loss of exponent. So 3 to the 3 cubed to the x plus 1. This is the same thing as 3 to the exponent 3 times x plus 1. And then this is going to be 3 to the exponent 4 times x minus 2. Now that they have the same base, the exponents have to also be the same or equal to each other. So therefore 3x plus 1, 3 times x plus 1 rather, is equals to 4 times x minus 2. Multiply it in 3x plus 3 equals to 4x minus 8. But the x's on one side and numbers on the other, so I can go 3x minus 4x equals to negative 8, and then bring that here is negative 3. It's going to be negative x equals to negative 11. So therefore x equals to 11. So x equals to 11. Okay, now let's see. We have a little bit of time. We could probably do letter C. We can do C and D. 9 to the x equals to 27, fourth root of 3. Oh my goodness. Okay, so this one is going to be interesting. Now it looks like, what could be my good base in here? 9 and 27 is could be written by base 3. So, and this one here is base 3 as well. So 9 is 3 squared. X equals to 27. That's the same thing as 3 cubed. Now, what about this one in here? How do we write that as a base 3? The radical can be written as exponents too. So this is the same thing as 3 exponent 1, and then the radical here is the denominator of the exponent. So that fourth root of 3 is the same thing as 3 to the 1/4. So how do we do this part? 3 to the 2x equals to 3 cubed times 3 to the 1/4. What do we do with that one? When we're multiplying powers, we add the exponents. This is the same thing as 3 to the exponent 3 and 1/4. 3 and 1/4. Now that they have the same base, that means the exponent is this is going to be the same. So this is going to be 3 and 1/4. So 2x is equals to 3 plus 1/4. Now, that's if we want, we can use 3 and 1/4. 2x. This we need to have the same denominator, so times this by 4, times it by 4, so that's going to be 12 plus 1, so 13 fourths, and then divide both sides by 2. Divide both sides by 2, so it's going to be 13 times 13 fourths, and then dividing it also by 2. So the answer is 13 eighths. This is kind of interesting because that's the answer. Okay, so we'll just finish off the letter D. I'll just go over here. This is going to be 5D. 5D. Cube root of 2 over 8 equals to 4 to the x. Now I realize that, hey, this is root of 2, so we can rewrite this as a radical, from radical to exponential form. 8 could be written as a base of 2. 4 could also be written as a base of 2. So it looks like this exponential equation can be written everything as a base of 2. So this part in here, that's the same thing as 2. Writing it as a rational exponent. So 2 to the 1/3. And then 8 could be 2 cubed. And then 4 would be 2 squared x. So what do we do when we have to divide by the same powers with the same base? We subtract exponents. So this is going to be 2 to the 1/3 minus 3 equals 2 to the 2x. Okay, now that they have the same base, that means our exponents have to be the same, have to be equal. So 1/3 minus 3 equals to 2x. If you want, we can, we need to have the same denominator in this particular case. The denominator is 3, so I'm going to multiply this by 3, multiply this by 3. So 1/3 minus 9/3 equals to 2x. Okay, so 1/3 minus 9/3, that's going to be negative 8/3 equals to 2x. And then I have to divide both sides by 2, divide by 2, so that becomes x is equals to negative 8 divided by 3 times 2. So x is equals to negative, that's too close, negative 8 over 6 equals to x. And of course, we can simplify that as negative 4/3 equals to x. Okay, there you have it. So we did up to questions 1 through 5 on these, the review questions. So I'm going to post all of these stuff that we talked about on the blog, including the summary. So again, just continue working on your review questions. Tomorrow I will continue on with solving some of these questions. If you have a specific questions that you want me to go over, either from the review or from the other practice questions, please let me know. And so go through as much as you can for the rest of the day today. And just send me an email if you have any questions with any of these. Okay, so leave that with you, and thank you very much for watching. Either if you're watching right now at the live stream, or if you're watching it later, thank you so much. Okay, so I'll talk to you later, and have a good day. Okay, bye for now.